Hello everyone. So today's topic is sequence and series. Sequence and series. So what is sequence? Sequence Sequence means collection of objects in an ordered manner. It means collection of objects in an ordered manner. For example, amount of money deposited in a bank, amount of money deposited in a bank over a number of years. And if a sequence follow any particular pattern, then it is called a progression. And if a sequence follow any particular pattern, then it is called progression. So progression are of two types. First is arithmetic progression. Arithmetic progression, also known as AP. And second is geometric progression, which is known as GP. So what is a term? What is a term? So various numbers occurring in a sequence are denoted by A1, A2, A3. Various numbers occurring in a sequence denoted by A1, A2, A3 and dash 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 AN. So what these numbers represent? 1, 2, 3, and it goes up to n. So if we have A, it is, and we have a subscript n. So this subscript is denote position of term. Denote position of term, and this denotes the name of term, name or value of a term, value of a term. So therefore A1 is first term and A2 is second term. Second term. Therefore it likewise we have an nth term, so it is called nth term. So nth term is also called as general term. For example, we have a progression 2, 4, 8, 16, 32, dash dash dash, and it goes up to 1024. So here 2 is a first term, 4 is a second term, 8 is a third term, 16 is a fourth term, 32 is a fifth term, and we have last term, nth term is 1024. Next, so this was about terms. Next is, what is a finite sequence? What is finite sequence? So a sequence containing finite number of terms is called a finite sequence. A sequence containing finite number of terms is called finite sequence. For example, 2, 4, 8, and it will go up to 10 terms. So this is not equal to a, this is 10 terms. That is 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. So now 1024 is nth term, a nth. So where n is equal to 10. So 2 is the first term, 4 is the second term, 8 is the third term, 16 is the fourth term, and it will go up to 10th term, that is 1024. So this is a finite sequence because here n is equal to 10, a finite number. What is a infinite sequence? What is a infinite sequence? A sequence containing infinite number of terms. A sequence containing infinite number of terms. For example, 3, 3.3, 3.33, and 3.333, 3.3333, and it will go up to infinite. So how to express sequence of infinite terms as a rule? How to express the sequence of infinite terms as a rule? So whenever there is a pattern in sequence, then we can express that sequence as a rule. So whenever there is a pattern in sequence, then we can express that sequence as a rule. For example, first we have sequence of even natural number. Sequence of even natural number. So we have 2, 4, 6, 8, 10, dash dash dash, and it will go up indefinitely to infinite. So if we see from first term, we have 2 cross 1, and second term is 2 cross 2, third term is 2 cross 3, and fourth term is 2 cross 4, fifth term is 2 cross 5, and it will go up to n term. So last term will be 2 cross n. So we have the nth term, an is equal to 2n. So we can call an is equal to 2n is a rule to find any term in a sequence of even natural number. So if n equal to 1, we get a equal to 2, a1 equal to 2, n equal to 2, then we get a2 equal to 4. If n equal to 3, we get a3 equal to 6, a4 8, and it will go. So an plus equal to 2n is a rule to find a term in a sequence of even natural number. So second is sequence of odd natural number. Sequence of odd natural number, that is 1 comma 3 comma 5 comma 7 comma, and it will go up to infinite. So we can write 1 as 2 cross 1 minus 1, and 3 as 2 cross 2 minus 1, and 5 as 2 cross 3 minus 1, and 7 as 2 cross 4 minus 1. So if you notice that the rule, the nth term will be 2 cross n minus 1. So 2n minus 1. So nth term is 2n minus 1. So likewise you can find sequence of other natural numbers by finding a rule. But there are some series where there is no visible pattern, but there are some series where there is no visible pattern, where there is no visible pattern. But sequence is generated by recurrence relation. But the sequence is generated by recurrence relation. For example, 1 comma 1 comma 2 comma 3 comma 5 comma 8, and dash 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 infinite. So we have a1 is 1, a2 is 1, and a3 is 2, and a4 is 3. So we can find a pattern. a1 is 1, a2 is 1. So if you look at a3, which is equal to 2, it is equal to a1 plus a2. Like a4 is equal to 3, which is equal to a3 plus a2, and we have a5 is equal to 5, so it is equal to a3 plus a4. So if it goes up to n, then it will be equal to an minus 2 plus an minus 1. So this is the rule which is generated by recurrence relation. So it is also known as Fibonacci series. Fibonacci series. Fibonacci series. And it is valid only when n is greater than 2. But some sequences cannot be expressed as a rule. There are some sequences. There are some sequences which cannot be expressed as a rule. Which cannot be expressed as a rule. For example, sequence of prime numbers. For example, sequence of prime numbers, that is 2, 3, 5, 7. So this sequence cannot be expressed as a rule. So now we can define a sequence as follows. What is sequence? So a sequence can be regarded as a function. A sequence can be regarded as a function whose domain is the set of natural numbers. Or some subset of it. Sometimes we use functional notation an, and sometimes we use functional notation an. So next is series. What is series? So let a1, a2, a3 be a sequence. Then the expression a1 plus a2 plus a3 plus dash 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 plus n. So then this expression is called a series. So there is a basic difference between sequence and series. There is in sequence there is a comma between terms of a sequence a1 comma a2 comma a3, and in series we add positive sign a1 plus a2 plus a3 and an. And here, so in sequence we have a comma in between the terms, and in series we have a addition sign. So whenever a sequence is terms of sequence are added, then it becomes a series. So series is represented by a sigma notation. By sigma notation. That is, this is sigma, which means summation of terms. Summation of terms, that is a1 plus a2 plus a3 dash 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 an is equal to summation k equal to 1 to n and ak. So we use the phrase sum of a series. So this denote the sum of a series. Sum of a series, that is sigma symbol denotes sum of series. Next is, so this was about sequence and series. So next is arithmetic progression. Arithmetic progression. So any sequence a1, a2, a3 is called arithmetic sequence or arithmetic progression if an plus 1 is equal to an plus d. A sequence a1, a2, a3 dash dash an is called arithmetic sequence or arithmetic progression if an plus 1 is equal to an plus d, that is where n belongs to natural numbers, and we have a series sequence a1 a2 dash dash an, so where a1 is first term, and from here d is, so we can write here d is a common difference between two terms, common difference so we can write a2 minus a1 is equal to d, a3 minus a2 equal to d, and this will goes up to an minus 1 equal to d, or an plus 1 minus an equal to d. So common difference remains same in arithmetic progression. If common difference vary over a range of terms, then it is not a arithmetic progression. So what is a standard form of arithmetic progression? Standard form of arithmetic progression, that is we have first term a, second term a plus d, third term a plus d plus d, fourth term a plus d plus d plus d, so it goes up to n terms. So we can also write it as follows: a is the first term, a plus d is the second term, a plus 2d is the third term, a plus 3d is the fourth term, and it will go up to nth term. So what is nth term? What is the rule of this sequence? What is the rule of this sequence? So we have a comma a plus d comma a plus 2d, so it will go up to n terms. So we have to find an. So an is equal to a plus n minus 1 d. So it is a general term, So why we have taken n minus 1? So if we consider a series a, comma a plus d, a plus 2d, a plus 3d, so it will go up to a plus n minus 1 d, and next term will be a plus nd. So if we look at the number of terms from a plus d, so a plus d, a plus 2d, a plus 3d, and up to n minus 1 we have n minus 1 terms, n minus 1 terms. So for nth term we add this first term to the n minus 1 terms. So that is why an is equal to a plus n minus 1 d. Or we can say if a is first term, then a plus d and a plus 2d dash dash a plus n minus 1 d, and next term will be a plus n d. So this whole number of terms in the bracket are equal to n minus 1 terms. So if we add one more term, that is first term, then it will become total number of n terms. So therefore an is equal to a plus n minus 1 d. So what are the properties of arithmetic progression? Properties of arithmetic progression. First is, if a constant is added to each term of an AP, then resulting sequence is an AP. If a constant is added to each term of an AP, then resulting sequence is AP. Second, if we subtract a constant term, if we subtract a constant from each term, then the resulting sequence will be AP. Third, if we multiply a constant by each term, then the sequence is AP. Next, we have fourth, if we divide each term by a non-zero term, if we divide each term by a non-zero constant, then resulting sequence will be AP. So next is, this was general term of AP. Next is sum of AP, sum of arithmetic progression. So if we have a series a plus d, a plus 2d and that dash a plus n minus 1d. So Sn is given by n by 2 a plus l, where Sn is equal to sum, l is equal to last term or equal to an, d is a common difference, and n is equal to number of terms, and a is a first term. A is a first term. So how we arrived at this rule of sum? So if we take a plus d plus a plus 2d and dash dash, and this is the last term which is equal to an. So if we write the second last term, it would be l minus d, because common difference is l. If we add l minus, subtract d from l, we get a second last term. Similarly, if we subtract a common difference from l minus d, we get the third last term, that is l minus 2d will be third last term, and l minus d l. So a sequence will look like this: a plus d, a plus 2d, and from last we see l minus d, comma l minus 2d dash dash dash. So let this is equal to s1. Next, if we start from last, if we reverse the sequence, if we reverse the sequence, that is s2 is equal to l plus l minus d plus l minus 2d dash dash dash. Then we have a plus 2d and a plus d and a. So we can write as s1 is equal to a plus d, a plus 2d, comma l minus 2d, comma l minus d, and last term. And s2 is l plus l minus d plus l minus 2d dash 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 plus a plus 2d plus a plus d plus a. So if we add both the two terms, we get s1 plus s2 is equal to, so this d will cancel out, this 2d and this 2d. So all we get is a plus l plus a plus l plus a plus l up to n terms. So we can write s1 plus s2 is equal to n times a plus l. And we also see that sum of terms in both the series are same, so s1 is equal to s2 is equal to s. So we can write s is equal to, so 2s is equal to n a plus l. So we get s is equal to n by 2 a plus l. So it is also called sum of n terms, which is equal to n by 2 a plus l. So this is how we get the sum of a sequence of arithmetic progression. We can also write this sum as n by 2 if we substitute the last term a. So last term is a plus n minus 1d. So we get Sn is equal to n by 2, and we get 2a plus n minus 1d. So this is a other way of writing sum of a sequence of arithmetic progression. So this is about sum of an AP. Next is arithmetic mean. So let there are two numbers A and B. So we can insert any number A. So let there are two numbers A and B. So we can insert any number A. We can insert any number A between A and B so that A comma A comma B are in AP. So where A is a arithmetic mean, where A is a arithmetic mean. So from a definition of arithmetic progression, the common difference is same, that is A difference between the first and second element is equal to difference between third and second element. So we can arrange the terms. 2A is equal to A plus B. So we get arithmetic mean as A plus B by 2. So this is how we get arithmetic mean between two numbers. So how many, next is how many numbers we can insert between A and B. How many numbers we can insert between A and B. So we can insert as many number as possible as we like, such that the resulting sequence is an AP. So we can insert as many number as we like, such that the resulting sequence is an AP. The resulting sequence is an AP. So let A1, A2, A3, A and B n numbers between A and B. Let A1, A2, A3 and AN be n numbers between A and B, such that A comma A1, A2 and dash 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 AN comma B is in AP. So if we have this is first element, this is second element, this is third element, and it will goes on till n, and this is last element. So we can see these are total number of n terms. This is the last term, and this is the first term. So total we have, so if we include the first term, with the arithmetic means we get n plus 1 terms. So accordingly this will be n plus 2th term. So total there are n plus 2 terms. N plus 2 terms. So from definition of AP, we have nth term will be a plus n minus 1 t, where n is equal to n plus 2. So we get a n plus 2 is equal to a plus, replace n by n plus 2 minus 1d. A n plus 2 is equal to a plus n plus 1d. So n plus 2th term is b. So if we replace a n plus 2 by b, we get a b equal to a plus n plus 1 d. So we get a common difference as follows: b minus a divided by n plus 1. So this is a common difference when we insert n number of arithmetic means between two numbers a and b. So therefore we can insert any number of terms in an AP. Therefore we can insert any number of terms in an AP. For example, if we insert six numbers between 3 and 24, insert 6 numbers between 3 and 24. So if we have 3 and we have 6 numbers a1, a2, a3, a4, a5, a6 and 24. So these are 6 terms. So there are total number of 8 terms, and we have 8 terms. So an is equal to a plus n minus 1d. So eighth term is 24 and first term is 3. So we get 8 minus 1 is d. So here 21 divided by 7. So we get common difference as 3. So if we write this sequence, we get 3 and a1, a2, a3, a4, a5, a6 and 24. So because common difference is 3, we get 3. If we add 3 to the first term, we get a1 as 6. We get that we add 3 to 6, we get 9. 9 plus 3 12, 12 plus 3 15, 15 plus 3 18, 18 plus 3 21 and 21 plus 3 24. So these are the 6 terms which are in AP: 6, 9, 12, 15, 18, 21. Next topic is geometric progression. Geometric progression. It is also known as GP. So suppose we have first 2, 4, 8, 16, dash dash dash. Second is 1 by 9 minus 1 by 27 and 1 by 81 dash dash dash. So if we look at the above examples, in first example if we see second term by first term is 2, third term by second term is 2, 8 by 4 is 2 and 16 by 8 is equal to 2. So we have a common ratio. Common ratio is equal to 2 in first sequence. Therefore it is a GP. Therefore it is a geometric progression. Second is 1 by 9 minus 1 by 27 and 1 by 81 minus 1 by 243. So if we divide subsequent terms, minus 1 by 27 by first term, 1 by 9 we get minus 1 by 3. Second, 1 by 81 divided by minus 1 by 27. So we get minus 1 by 3. So we in this sequence we have a common ratio of 1 by 3 minus 1 by 3. So whenever in a sequence we get a common ratio, then it can be considered as a geometric progression. Whenever we get a common ratio in a sequence, then it can be considered as geometric progression. So if we in general, if we have a1, a2, a3 dash 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 an in is a geometric progression, then we have a k plus 1 divided by ak is equal to r is equal to constant, where k is greater than equal to 1. So what is a standard form of geometric progression? A standard form of GP. So standard form is a comma ar comma ar square, and it will goes up to ar n minus 1. So why ar n minus 1? Because these are total number of n minus 1 terms, and to have total number of n terms, we add a first term to n minus 1 terms, so it total becomes n terms. So that is why the last term is a r n minus 1. Therefore last term is a r n minus 1. So we can also call it as nth term. So what is the sum of GP? Sum of GP. So we have, if we write Sn is equal to a plus ar plus ar square plus dash 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 ar n minus 1, and if you multiply the equation by r, Sn ar plus ar square plus ar cube, and we have ar n, and if we subtract these two equations, then we get 1 minus r Sn, and this will cancel out, this will cancel out, and this goes till ar n minus 1, this will also cancel out, so a minus ar n. So we get a 1 minus r n divided by 1 minus r. So this is a sum of a sequence of geometric progression. So there are two cases in writing sum of geometric progression. First is when r is greater than 1, and second is r is less than 1. So for So for r greater than 1, we have Sn is equal to a r n minus 1 divided by r minus 1. And second, for r less than 1, we have Sn a 1 minus r n divided by 1 minus r. So this was about some of terms of geometric progression. Next is geometric mean. Also, uh, where a is first term and r is a common ratio, and n is number of terms. So what is the geometric mean of two positive numbers a and b? Geometric mean of any two positive number is equal to root of ab, that is gm of 2 and 8 is equal to 2 into 8, that is equal to 4. So we can insert as many number between a and b. So we can insert as many number between a and b, that is a comma g1 comma g2 comma g3 dash 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 comma gn and comma b. So these are total number of n terms. So this is the last term, a r n minus 1 n plus 1. And this is the first term. So this is similar to the previous case of arithmetic progression. So these are n terms. This will be n plus 2th term. So there are these total number of terms are n plus 1 terms, and total number there are n plus 2 terms, n plus 2 terms. So we can write b as a general term, a r n minus 1. So where n is equal to n plus 2. So b is equal to a r n plus 2 minus 1, which is equal to a r n plus 1. So if we find a common difference, we get b by a to the power 1 by n plus 1. Therefore, we can insert as many numbers as possible between a and b if we have a common difference of b by a to the power 1 by n plus 1. So the question is, insert three numbers between 1 and 256 so that the resulting sequence is a GP. So that the resulting sequence is a GP. So first is 1 comma G1 comma G2 comma G3 and last is 256. So these are total number of 3 terms. So this is fourth term and this is first term. So total number there are 4 terms. So if we write 256 last term as a r n minus 1, so a r cube 256. So this is so this is fifth term, and there are total number of 5 terms. So we get 256 is equal to AR. Total number of terms are 5. So we get AR4 256. So here R is equal to 4 because A is equal to 1. So we have a common ratio of R is equal to 4. Therefore, we can insert 3 numbers G1, G2 and G3, and last term is 256. By multiplying the each term by 4, we get a geometric progression 1 into 4 and 4 into 4, 16 into 4, and last is 256. So 1 comma 4 comma 16 comma 64 comma 256. So the resulting sequence is a GP, and G1, G2, G3 are G1 is equal to 4, G2 is equal to 16, and G3 is equal to 64. So this is how we can find any number of terms between any two numbers. Next is, what is a relationship between arithmetic mean and geometric mean? What is a relation between arithmetic mean and geometric mean? So A is equal to A plus B by 2, and G is equal to root of AB, and A minus G, we can write A minus G as A plus B by 2 minus root of AB, where A plus B minus 2 root A into root B divided by 2. So we know A minus B whole square is A square plus B square minus 2AB. So we can write root A minus root B whole square divided by 2, which is a positive quantity. So we can say AM is minus GM is greater than 0. So AM is always greater than GM. So this is a very important relationship between AM and GM. So based on AM and GM, many logical deductions are made. Based on this relation, many logical deductions are made. Next is sum of n terms of a spatial series. Sum to n terms of a spatial series. So series we have series means summation, sigma, summation. So there are 3 types of spatial series. First is 1 plus 2 plus 3 plus dash 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 plus n. So it is known as sum of natural numbers. Sum of natural numbers. Second is 1 square plus 2 square plus 3 square plus dash 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 plus n square. So we this is a special series which is known as sum of square of natural numbers. Sum of square of natural numbers. And third is 1 cube plus 2 cube plus 3 cube dot dash 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 plus n cube, which is known as sum of cube of natural numbers. Sum of cube of natural numbers. So we will first find the sum of natural numbers. First, sum of natural numbers, that is 1 plus 2 plus 3 plus n. So we notice here that it is an AP where common difference is 1 because 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, and n minus 1 is equal to 1. So we can call it sum of natural numbers as AP. So we know how to write a sum of natural numbers, that is n by 2 first term plus last term. Therefore n by 2 first term is 1 and last term is n. So sum of natural numbers are Sn is equal to n bracket n plus 1 by 2. So this is the sum to n terms of a special series which is called as sum of natural numbers. Second is sum of square of natural numbers. Sum of square of natural numbers. So let's take an identity k cube minus k minus 1 whole cube is equal to 3k square minus 3k plus 1. So if we start with k equal to 1, we get 1 cube minus 0 cube equal to 3, 1 square minus 3 bracket 1 plus 1. And if we put k is equal to 2, then we have 2 cube minus 1 cube is equal to 3, 2 square minus 3, 2 plus 1. At k equal to 3, 3 cube minus 2 cube is equal to 3, 3 square minus 3, 3 plus 1. So at k equal to n, n cube minus n minus 1 whole cube and 3 n square minus 3 n plus 1. So if we add all the terms, then 1 cube get cancel out, 2 cube get cancel out, and 3 cube like n minus 1 whole cube, it will also cancel out. So we are left with n cube is equal to 3, 1 square plus 2 square plus n square minus 3, 1 plus 2 dash 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 n, and we have 1, 1 plus 1 plus 1 plus 1 till n. So we have n cube is equal to 3, 1 square plus 2 square dash 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 n square and minus 3, 1 plus 2 plus dash 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 n plus. So we can write it if we write it as n, because sum of 1 up to n is equal to n. So total sum is equal to n. So this sum will be Sn, which we have to find, and this is sum of natural numbers. We denote it as S1, and it will remain as it is. So n cube, this will go to left side, n minus n is equal to 3Sn minus 3S1. So if we get, we have 3Sn is equal to n cube minus n plus 3S1, where S1 is equal to sum of natural numbers, which we have derived earlier. So substitute S1 in equation 1, substitute here S1. So here Sn, 3Sn is equal to n cube minus n plus 3 n bracket n plus 1 divided by 2. So we have 3Sn is equal to n cube, 2n cube minus 2n plus 3n square plus 3n divided by 2. So Sn is equal to 2n cube minus 2n plus 3n square plus 3n divided by 6. So if we take 2n common, we have n square minus 1 bracket 3 n n plus 1 divided by 6. So we can write n plus 1 bracket 2n n minus 1 plus 3n divided by 6. So we can write n plus 1 2n square minus 2n plus 3n divided by 6 equal to n plus 1 and n plus 2n square divided by 6. So we get sum of square of natural numbers as n bracket 1 plus 2n bracket n plus 1 divided by 6. So this is sum of square of natural numbers. Last is sum of cube of natural numbers. Sum of cube of natural numbers, that is 1 cube plus 2 cube plus n cube is equal to Sn. So like we used the identity in sum of square of natural numbers, so here we will use another identity, k plus 1 4 minus k4 is equal to 4k cube and 6k square plus 4k plus 1. So in this also we will substitute k equal to 1 till k equal to n, and we apply the summation formula in the end. The process is same as the sum of a square of natural numbers. So the result will be Sn of sum of cube of natural numbers will be n bracket n plus 1 by 2 whole square. So so we can write it as sum of natural numbers is equal to n bracket n plus 1 by 2. Second, sum of square of natural numbers is equal to n bracket 2n plus 1 n plus 1 divided by 6. And third, sum of cube of natural numbers, which is equal to n bracket n plus 1 by 2. whole square. So this was about sum to n terms of spatial series. So this was all about sequence and series, and arithmetic progression and geometric progression, and arithmetic mean and geometric mean. So thank you.